The sun is there, the way it's always been there, present in a way that makes it easy to forget about until you happen to think of it. And then suddenly it seems remarkable that such a thing exists at all, this massive sphere of light and heat suspended in space, burning without sound, without needing anything from us, just existing on its own terms, following patterns that were established long before anyone was here to observe them. It's far away, the sun. Much farther than it looks when you see it in the sky, appearing as a bright disk that seems close enough to touch if you could just reach high enough. But the distance is vast, the kind of distance that's difficult to comprehend because human experience doesn't prepare us for distances measured in the time it takes light to travel. Light which moves faster than anything else we know about, crossing the space between the sun and here in a little over 8 minutes, which sounds quick until you consider that light could circle the Earth more than 7 times in a single second, and even moving at that speed it takes 8 minutes to arrive from the sun, which gives some sense of the gap, the emptiness between there and here. The light that's arriving now if it's daytime where you are, or the light that arrived earlier if it's night, that light left the sun 8 minutes ago, which means you're always seeing the sun as it was, not as it is, looking at the past every time you glance up at the sky. 8 minutes isn't long in most contexts, barely enough time to boil water or walk a few blocks, but it's long enough that things could change. Theoretically, something could happen to the sun in those 8 minutes and we wouldn't know yet, wouldn't see it until the light carrying that information reached us, traveling across the void at its constant speed, bringing news that's already old by the time it arrives. But the sun doesn't change much in 8 minutes. It doesn't change much in a day or a year or a human lifetime. The changes that happen in the sun are slow, unfolding over timescales that make human history seem brief, that put our entire existence as a species into perspective as something recent, something that happened very late in the sun's story, near the middle of its life perhaps, though middle is an approximation, a guess based on understanding of how stars work, how they burn through their fuel and what happens when that fuel begins to run low, processes that are still happening in the sun right now, deep in its core where the pressure is so intense and the temperature so high that hydrogen atoms are being forced together, fusing into helium, releasing energy in the process, energy that works its way outward from the core through layers of the sun, taking thousands of years to make the journey from the center to the surface, and then 8 more minutes to travel from the surface to here. The core of the sun is not a place anyone could visit. Even in imagination it's difficult to hold in mind because the conditions there are so extreme, so far beyond anything experienced on Earth. The temperature at the core is somewhere around 15 million degrees, though degrees is a measurement that was invented for much smaller ranges of heat, for the difference between freezing and boiling or between a cool day and a warm one, and applying it to 15 million feels almost absurd, like using inches to measure the distance to another galaxy, technically possible but not really suited to the scale. At that temperature, matter doesn't behave the way it behaves here. There are no solids, no liquids in any familiar sense, just plasma, which is what happens when matter gets so hot that electrons are stripped away from atoms, everything becoming electrically charged particles moving at tremendous speeds, colliding constantly, creating the conditions where fusion can occur. Fusion is how the sun makes its energy, how it's been making energy for about 4.5 billion years, which is a span of time that's difficult to conceptualize, though perhaps it helps to think about what was happening on Earth at different points during that span. 4.5 billion years ago, when the sun was new, still contracting from the cloud of gas and dust that formed it, the Earth was also new or newish, still mostly molten, being bombarded by asteroids and comets, not yet stable enough to support any kind of life. A billion years later, the sun was still there, burning steadily, and the Earth had cooled enough that oceans formed, and somewhere in those oceans, somehow life began, single cells that would eventually become everything else, all the complexity of biology emerging from those simple beginnings, diversifying and adapting and filling every available niche over the next 3.5 billion years, and through all of that time the sun was there, providing light, providing warmth, driving the weather, enabling photosynthesis once plants evolved, making everything possible in a fundamental way that's easy to overlook because it's so constant, so reliable that it becomes background, something assumed rather than noticed. The sun doesn't orbit the Earth, though it looks like it does if you watch from the surface, if you track its path across the sky from sunrise to sunset, an arc that seems to show the sun moving around us, rising in the east and setting in the west with predictable regularity. It took humans a long time to realize that this appearance is misleading, that actually the Earth is orbiting the sun, spinning on its axis as it moves through space, and that the sun only appears to move because we're the ones moving, our perspective rotating as the planet turns, bringing different parts of the surface into alignment with the sun's light and then rotating those same parts away into darkness, creating the cycle of day and night that structures so much of life that determines when most creatures sleep and wake, when plants open their flowers or close them, when temperatures rise and fall in their daily rhythm. The Earth takes about 24 hours to complete one rotation, though not exactly 24 hours, it's slightly less than that, close enough that the difference doesn't matter for most purposes but significant enough that it accumulates over time, requiring adjustments, leap seconds added occasionally to keep our clocks synchronized with the actual position of the planet. The Earth also wobbles slightly as it rotates, a small irregularity in its spin caused by the distribution of mass, by ocean sloshing and by the gravitational pull of the moon, which is close enough to have noticeable effects, raising tides and stabilizing the Earth's tilt, keeping the axis of rotation at a relatively constant angle, which is part of what makes the climate stable enough for complex life to exist. Though stable is relative, things are always changing, just slowly enough that most of the changes aren't perceptible within a single lifetime. While the Earth rotates, it also orbits the sun, tracing an elliptical path through space, not a perfect circle but close to one, varying in distance from the sun by a few million miles over the course of a year, though a few million miles sounds like a lot but represents only a small percentage of the total distance, not enough to have a major effect on temperature, not the reason for seasons, which are caused instead by the tilt of the Earth's axis, the way the North Pole leans toward the sun during part of the orbit and away from it during another part, changing the angle at which sunlight strikes different parts of the surface, concentrating the light more directly during summer and spreading it more thinly during winter, at least in the hemisphere that's tilted away. At the equator, the sun is almost directly overhead at noon throughout the year, the light coming straight down or nearly so, heating the surface intensely, creating the warm climate that exists in tropical regions, where the temperature doesn't vary much between seasons because the angle of sunlight doesn't vary much, staying relatively constant while the regions farther north and south experience larger swings, colder winters and warmer summers, the difference becoming more pronounced the closer you get to the poles, where the tilt has the most dramatic effect, creating places where the sun doesn't set for months during summer and doesn't rise for months during winter, continuous daylight and continuous darkness, extremes that seem strange from the perspective of temperate latitudes where day and night alternate regularly, where you can count on the sun appearing every morning and disappearing every evening, reliable as anything in nature can be reliable. The sun itself doesn't rise or set, of course, it stays where it is, more or less, moving through the galaxy along with the entire solar system but not rising or setting in any absolute sense, just appearing to do so from our rotating perspective, which is the only perspective we have, the view from here, from the surface of this particular planet at this particular distance from this particular star. Other planets have different views. Mercury, being much closer to the sun, experiences much more intense sunlight, the surface heating to temperatures that would melt lead during the day and cooling to extreme cold at night because there's no atmosphere to hold the heat, no air to distribute it or to moderate the extremes. Venus has an atmosphere, a very thick one, but it creates conditions that are even more hostile, trapping heat through an intense greenhouse effect, making the surface hot enough to melt certain metals, hotter than Mercury despite being farther from the sun, an example of how atmosphere matters as much as distance, how the way a planet interacts with its star's energy determines conditions on the surface. Mars is farther from the sun than Earth, receiving less light, less warmth, and its atmosphere is thin, almost not there, so the surface is cold, averaging well below freezing, though it varies depending on latitude and season and time of day, warming slightly in the afternoon near the equator, cold enough at the poles that carbon dioxide freezes out of the atmosphere and accumulates as ice. The sun appears smaller in the Martian sky than it does from Earth, a visible reminder of the greater distance, the way objects shrink with distance, following mathematical rules that are predictable and consistent, the apparent size decreasing proportionally as the distance increases, so that from Mars the sun is only about 2/3 the width it appears from Earth, still bright enough to illuminate the landscape but dimmer, casting weaker shadows, providing less energy for any solar panels that might be deployed on the surface to collect light and convert it to electricity, a process that mimics in a simplified mechanical way what plants do through photosynthesis, capturing energy from sunlight and transforming it into a different form, something that can be stored and used later. Photosynthesis is one of the fundamental processes that makes life on Earth possible. The way that energy from the sun enters the biological systems that depend on it, plants and algae and certain bacteria absorbing photons of light and using that energy to split water molecules, separating hydrogen from oxygen, using the hydrogen to build sugars and releasing the oxygen as a byproduct, which is fortunate for organisms like us that breathe oxygen, that require it to survive our existence. Depending on the waste product of photosynthetic organisms, an interdependency that connects everything, plants and animals and the atmosphere and the sun, all of it linked in cycles that operate at different scales, some of them quick like breathing and some of them slow like the carbon cycle that moves carbon between air and ocean and rock over millions of years. The light from the sun contains different wavelengths, different colors, though color is something that happens in the perception of the light rather than being an inherent property of the light itself, wavelengths of electromagnetic radiation that our eyes detect and our brains interpret as red or blue or green or yellow. The sun emits light across a wide range of wavelengths, from ultraviolet, which is too short for our eyes to see, to infrared, which is too long, with visible light occupying the narrow band between those extremes, the wavelengths that correspond to the colors of the rainbow, which appears when sunlight passes through water droplets and gets refracted, bent at slightly different angles depending on wavelength, spreading the light into its component colors, making visible the spectrum that's usually mixed together into white light, though white is not really a color but the presence of all colors, all wavelengths combined in relatively equal amounts. The sun looks yellow from the surface of the Earth, or sometimes orange or red, especially near sunrise or sunset when the light has to pass through more atmosphere, scattering the shorter wavelengths and leaving the longer ones. But from space the sun would look white or maybe slightly blue-white, closer to its true color, which is determined by its temperature, hotter stars appearing blue and cooler stars appearing red, with the sun somewhere in the middle, yellow-white, what astronomers classify as a G-type main sequence star, which sounds technical but really just means it's a medium-sized star that's in the stable phase of its life, fusing hydrogen in its core, not a giant and not a dwarf, not particularly young and not particularly old, just an ordinary star, one of hundreds of billions in the galaxy, probably similar to countless other stars scattered throughout the universe. From the perspective of the sun, if the sun had a perspective, the Earth would be barely visible, a tiny blue dot orbiting at a distance, one of 8 planets in the solar system, 9 if you count Pluto, though the definition of planet has changed and Pluto is now classified as a dwarf planet, a different category, not because it changed but because our understanding changed, our system of classification becoming more refined as more objects were discovered beyond Neptune, in the region called the Kuiper Belt, where there are thousands of icy bodies orbiting the sun, most of them small but some of them comparable to Pluto in size, which raised questions about what should count as a planet and what shouldn't, questions that were eventually resolved by agreeing on a definition that excluded Pluto, a decision that some people found controversial or disappointing, though the object itself remained unchanged, still there in its orbit, still the same size and mass and composition regardless of what category we assign it to. The sun's light takes longer to reach the outer planets, longer than the 8 minutes it takes to reach Earth, 45 minutes to reach Jupiter, which is much farther out, orbiting at a distance where the sun appears smaller in the sky, less bright, providing less warmth, though Jupiter generates its own heat, radiating more energy into space than it receives from the Sun, heat left over from its formation, from the gravitational compression that created the planet, energy that's been slowly leaking out for billions of years and will continue leaking out for billions more, gradually cooling, though gradually here means over timescales that are almost impossible to imagine. Changes that happen so slowly that they're imperceptible, undetectable except through precise measurements taken over many years, compared and analyzed to reveal trends that would otherwise be invisible. Beyond Jupiter there's Saturn with its rings, and beyond Saturn there's Uranus and Neptune, ice giants orbiting in the cold outer reaches of the solar system where sunlight is so dim that it wouldn't provide much illumination, where the sun would look like a very bright star but not like the overwhelming source of light it appears from Earth, where it dominates the sky, where its presence or absence defines day and night, where its heat drives weather, where its light enables vision, where so much of existence is oriented around it without most of us thinking about it most of the time. The sun just there, reliable, constant, easy to forget about until there's an eclipse or an unusual sunset or a moment when you happen to notice it and remember what it is, this enormous ball of fusing hydrogen 93 million miles away, burning without needing us, without depending on anything we do or don't do, just following the physics of its own nature, converting mass to energy according to equations that were worked out in the early 20th century, E=mc², Einstein's famous equation that shows the relationship between mass and energy, how a small amount of mass can be converted into a large amount of energy, which is what happens in the sun, for million tons of matter converted to energy every second, which sounds like a lot and is a lot by any human measure but represents only a tiny fraction of the sun's total mass, so tiny that the sun can continue this process for billions of years without using up a significant portion of its fuel. The sun has already been burning for about half its expected lifetime, 4.5 billion years down, another 4.5 or 5 billion years to go, though to go is maybe not the right phrase since the sun isn't going anywhere. It's staying right where it is, relatively speaking, moving through the galaxy but not in a way that affects the solar system significantly, the planets moving with it, everything held together by gravity, the sun's mass creating a gravitational field that reaches out across vast distances, keeping the planets in their orbits, preventing them from flying off into space, providing the invisible force that structures the solar system, that gives it stability, that makes it possible for planets to orbit for billions of years without colliding or being flung away. Gravity is one of those things that's simultaneously obvious and mysterious, obvious in its effects. Everything falls down, objects attract each other, the Earth orbits the sun, but mysterious in what it actually is, what causes it, why mass creates this force that acts at a distance without requiring any medium to travel through, no air or water or substance connecting the objects, just empty space, and somehow the force still operates, still pulls things together, still keeps the moon orbiting the Earth and the Earth orbiting the sun, working according to laws that can be described mathematically, that can be used to make predictions that turn out to be accurate, but without anyone fully understanding why those laws exist, why the universe operates this way rather than some other way. The sun will continue as it is for a long time, maintaining the conditions that allow life on Earth to exist until eventually, in the distant future, billions of years from now, it will begin to run low on hydrogen in its core, and when that happens the core will contract, getting hotter, hot enough to start fusing helium into heavier elements, and the outer layers of the sun will expand, swelling into a red giant, growing larger and larger until it engulfs Mercury and Venus and possibly Earth. Though the exact trajectory is uncertain, depending on factors that are difficult to predict, on how much mass the sun loses during its expansion, on how that mass loss affects the gravitational relationships between the sun and the planets. But all of this is so far in the future that it has no practical relevance to anything happening now, no bearing on any decisions or concerns or plans, just a fact about the ultimate fate of the solar system, the way things will eventually change after an almost unimaginable span of time. Time enough for evolution to produce countless new forms of life if life survives that long. Time enough for continents to shift and mountains to rise and erode away multiple times. Time enough for the species that exist now to go extinct and be replaced by others that don't exist yet, that haven't evolved yet, that will come into being through processes we can't predict, adaptive responses to environments that don't exist yet, to challenges and opportunities that will arise over the slow unfolding of millions and millions of years. But for now, for the present and the foreseeable future, the sun is stable, burning steadily, providing the energy that drives everything, that makes the wind blow by heating air unevenly, that makes water evaporate and form clouds that produce rain, that makes plants grow and produce oxygen, that warms the surface during the day and whose absence allows it to cool at night, creating the rhythms that life has adapted to, that are built into biological clocks, internal timers that evolve to match the external cycle of day and night, systems that tell organisms when to sleep and when to wake, when to be active and when to rest, patterns that are so deeply embedded that they continue even in the absence of external cues. People kept in constant darkness still following roughly a 24-hour cycle. Their bodies expecting day and night even when those cues aren't present, showing how fundamental the sun's rhythm has become to the way life on Earth is organized. There are places on Earth where the sun's presence is more obvious, places like deserts where there's little shade, where the sun beats down on sand and rock, heating the surface to temperatures that can burn skin, where the intensity of the light is almost overwhelming, where everything is bleached and bright and the shadows are sharp and dark when they exist at all, which is only when something rises above the flat expanse enough to block the light, a rock or a cactus or a person, casting a shadow that's a small relief, a pocket of shade where the temperature is slightly lower, noticeably cooler than the surrounding area. Enough that animals seek out shade during the hottest parts of the day, finding places to rest where they're protected from direct sunlight, waiting for the sun to drop lower, for the shadows to lengthen, for the air to begin cooling as the surface stops receiving energy faster than it can radiate it away. In forests, the sun is filtered through leaves, its light scattered and softened, creating a dappled pattern on the ground where patches of brightness alternate with patches of shade. The pattern shifting as the wind moves the branches, as the leaves rustle and sway, changing the path of light, directing it to different spots on the forest floor where it falls on moss or ferns or fallen leaves, warming whatever it touches, driving photosynthesis in the plants that grow in those temporary pools of light, plants that have adapted to low light conditions, that can make use of the brief moments when direct sunlight reaches them, storing energy for the times when they're in shadow, when the canopy above blocks the light and they have to survive on whatever reserves they've built up. The canopy itself is where most of the light is captured, up high where the leaves of tall trees spread out, competing for access to sunlight, growing in whatever direction allows them to maximize their exposure, sometimes spreading horizontally to fill gaps in the canopy, sometimes growing taller to rise above neighboring trees. An ongoing competition that shapes the forest, that determines which trees survive and which don't, which ones get enough light to produce seeds and which ones remain stunted, limited by the shade cast by others, waiting for a gap to open, for a large tree to fall and let light flood in, creating an opportunity for growth, for younger trees to surge upward, racing to fill the space before it closes again as neighboring trees expand their crowns into the opening. Light from the sun travels in straight lines, more or less, bent slightly by gravity when it passes near massive objects but straight enough for practical purposes. Photons moving in straight paths from the sun through space, through the thin outer layers of Earth's atmosphere where there's not enough air to scatter them significantly. Only when they reach the denser layers lower down does scattering become noticeable. Does the light begin to bounce off air molecules, changing direction, spreading out, which is why the sky is bright during the day even when you're not looking directly at the sun? the light scattered in all directions, coming from everywhere at once, filling the sky with blue, or with other colors at sunrise and sunset when the light has to travel through more atmosphere, through more air that scatters the blue and green wavelengths and lets the reds and oranges pass through, painting the sky in warm colors that last for a brief period, a transition between day and night that can be spectacular or subtle depending on atmospheric conditions, on the amount of dust or moisture in the air, on the angle of the sun and the position of clouds, variables that ensure no two sunrises or sunsets are exactly alike. The sun's light has been traveling for 8 minutes when it reaches Earth, but before that it spent thousands of years working its way out from the core, energy generated in the core through fusion, released as high-energy gamma rays that immediately collide with matter, getting absorbed and re-emitted, over and over, each interaction changing the direction slightly, the energy bouncing around inside the sun in a random walk, a path that takes it slowly outward. The energy gradually working its way from the core to the radiative zone where it continues bouncing between particles, taking thousands of years to cross this region, the photons being absorbed and re-emitted countless times, each absorption and emission taking a tiny fraction of a second, but the total distance being so vast that even with all those interactions happening quickly, the overall progress is slow, incremental, the energy diffusing outward gradually until it reaches the convective zone, where the process changes, where the energy is carried by bulk movement of material, hot plasma rising to the surface, cooling and sinking back down, creating circulation patterns, loops of material that transport energy more efficiently than radiation, carrying it the rest of the way to the surface where it's finally released into space as light and heat, as electromagnetic radiation that spreads outward in all directions, some of it eventually reaching Earth after its 8-minute journey. Through the vacuum. The vacuum between the sun and Earth is not completely empty. There are particles there, sparse but present, mostly protons and electrons streaming outward from the sun, the solar wind, a continuous flow of charged particles that extends throughout the solar system, creating a bubble around the sun, the heliosphere, within which the solar wind dominates over the interstellar medium, the even more diffuse material that fills the space between stars. The solar wind travels at hundreds of kilometers per second, much slower than light but still fast by any human measure, fast enough to reach Earth in a few days, fast enough to interact with Earth's magnetic field, funneling particles toward the poles where they collide with the atmosphere, exciting atoms and molecules, causing them to emit light, creating the auroras, the northern and southern lights, curtains of green and sometimes red or purple or blue light that wave and shimmer in the night sky near the polar regions, visible evidence of the sun's influence, of particles from the sun colliding with atoms 93 million miles away, making them glow, creating beauty that's a byproduct of physics, of charged particles following magnetic field lines and transferring energy to atmospheric gases. The sun has been worshipped by many cultures throughout human history, seen as a deity or as a physical manifestation of divine power, which makes sense given how essential it is, how its presence or absence determines so much about daily life, about whether crops grow, about whether people are warm or cold, about whether there's light to see by, though humans eventually developed artificial light, fire first and then candles and oil lamps and eventually electric lights, technologies that extend the day, that allow activity after sunset, that make us less dependent on the sun's schedule, though the schedule still affects us, still shapes when we sleep and wake, still drives biological processes that evolved over millions of years and that don't change just because we've invented ways to light the darkness. The sun rises every day, or appears to, the Earth rotating to bring each location into alignment with the light, the boundary between day and night sweeping across the surface as the planet spins. A line that moves steadily westward at about 1,000 miles per hour at the equator, slower at higher latitudes where the distance around the Earth is less, the speed of rotation decreasing as you move toward the poles where at the exact pole you just spin in place. rotating once every 24 hours without moving laterally at all, though there's nothing at the exact North Pole except ice floating on the Arctic Ocean, ice that drifts and breaks up and reforms, moving with currents and wind, making the precise location of the pole a theoretical point rather than a fixed physical location. Coordinates that you could navigate to, but that wouldn't be marked by anything permanent, just water and ice and the abstract satisfaction of being at 90 degrees north, as far north as it's possible to go, where every direction is south. At the North Pole during summer, the sun circles the sky without setting, staying above the horizon 24 hours a day for months, gradually spiraling lower as summer progresses toward autumn, until finally it touches the horizon at the equinox and dips below, beginning 6 months of darkness, or not complete darkness because there's still twilight. The sun is below the horizon but not far below, its light still reaching the upper atmosphere and scattering, providing dim illumination, enough to see by on clear days even though the sun itself isn't visible. A strange half-light that persists for weeks during the transition between day and night, before the sun sinks far enough below the horizon that true darkness arrives and the stars become visible, constellations that will overhead, moving through their own patterns as the Earth continues to orbit the sun, changing the night sky gradually over the course of months, different constellations visible at different times of year, the same stars that ancient people looked at and formed into patterns, connecting them with imaginary lines, creating pictures and stories, ways of organizing and remembering the stars, making the sky legible. The sun itself is a star, similar to many of the stars visible at night, though most of the visible stars are actually more massive and more luminous than the sun, brighter intrinsically, which is why they're visible despite being incredibly far away. Distances measured in light years, the distance light travels in a year, which is about 6 trillion miles, a unit of measurement that's necessary because the distances to stars are so vast that regular units like miles or kilometers become unwieldy, the numbers too large to be meaningful. The nearest star beyond the sun is Proxima Centauri, a little over 4 light-years away, which means the light we see from it left that star 4 years ago. We're seeing it as it was in the past. And if something happened to that star, if it exploded or went dark, we wouldn't know for 4 years, not until the light carrying that information reached us, traveling across the empty space between the stars. Most stars exist in groups, binary systems where 2 stars orbit each other, or larger systems with 3 or more stars, gravitationally bound, circling a common center of mass. Though the sun is alone or mostly alone, it's sometimes suggested that it might have a very distant companion, another star orbiting at such a great distance that it hasn't been detected yet. But this is speculative, based on patterns in comet orbits that some scientists think might indicate a massive object in the far outer solar system, perturbing those orbits slightly, though other explanations are possible and the evidence is ambiguous, not conclusive enough to confirm the existence of another star, which would be very faint and very far away, barely gravitationally bound to the sun, orbiting at a distance measured in light years, taking millions of years to complete one orbit, so long that the concept of orbit almost loses meaning, the motion so slow that it would be imperceptible. The sun appears to move through the sky in a predictable path, rising in the east and setting in the west, but the exact point where it rises and sets changes throughout the year, shifting north and south along the horizon depending on the season, reaching its northernmost point at the summer solstice in June and its southernmost point at the winter solstice in December, at least in the northern hemisphere, the pattern reversed in the southern hemisphere where June is winter and December is summer, the seasons opposite but the mechanism the same, the tilt of the Earth's axis causing different hemispheres to receive more direct sunlight at different times of year, creating the annual cycle of seasons that's subtle near the equator where the sun is always nearly overhead and dramatic near the poles where the sun's path varies from constant daylight to constant darkness. At the equinoxes in March and September, the sun rises directly in the east and sets directly in the west, and day and night are approximately equal in length everywhere on Earth, equinox meaning equal night, though the equality is approximate, not exact, because of atmospheric refraction and because of how sunrise and sunset are defined, the sun being considered to rise when the top edge of its disk becomes visible above the horizon, and to set when the top edge disappears below it, which means the sun is actually slightly below the geometric horizon at sunrise and sunset, its light bent by the atmosphere, refracted around the curve of the Earth, extending the day by a few minutes beyond what would be expected based purely on geometry. A small effect but noticeable if you're measuring carefully, if you're trying to predict exactly when sunrise or sunset will occur at a particular location on a particular day. The sun's energy reaches Earth as a mix of light and heat, electromagnetic radiation across a range of wavelengths, some of it absorbed by the atmosphere, some of it reflected back into space, and some of it reaching the surface where it's absorbed by land or water, warming whatever it touches, driving the temperature up during the day until the sun sets and the surface begins to cool, radiating heat back into space, the temperature dropping through the night until the sun rises again, and the cycle repeats. This daily rhythm of heating and cooling creating temperature patterns that vary by location and season, hot deserts and cold polar regions, tropical forests and temperate zones. Each climate zone characterized by different patterns of temperature and precipitation. Patterns that are ultimately driven by the sun, by the uneven heating of the Earth's surface, warm air rising near the equator and cool air sinking near the poles, creating circulation patterns in the atmosphere, winds that blow from high pressure to low pressure, carrying heat and moisture, distributing the sun's energy around the planet, moderating the extremes that would exist if there were no atmosphere, no winds to transport heat from warm regions to cool ones. The oceans also transport heat, currents flowing through the water, some driven by wind and some by differences in water density, warm water at the surface and cold water at depth, moving in great circular patterns called gyres, rotating clockwise in the northern hemisphere and counterclockwise in the southern hemisphere because of the Coriolis effect, the way the rotation of the Earth deflects moving fluids, bending their paths, creating the spiral patterns that are visible in satellite images. Of ocean currents, beautiful structures that emerge from the combination of solar heating and planetary rotation. Patterns that are stable enough to persist year after year, but that shift and vary with seasonal changes, with the strengthening and weakening of winds, with events like El Niño that alter the usual patterns, warming parts of the ocean that are usually cool, changing weather patterns around the globe, bringing drought to some regions and floods to others, demonstrating how interconnected everything is, how a change in one part of the system propagates through the rest, creating effects that can be felt thousands of miles away. The sun will set tonight, if it hasn't already, or it will rise tomorrow, depending on where you are and what time it is, the Earth turning, carrying your location through the boundary between light and dark, bringing day or night, the transition happening gradually, not an instant switch but a slow change, the sky brightening or darkening over the course of minutes, colors shifting from black to deep blue to lighter blue to the pale blue of daytime, or the reverse at dusk, the light fading, colors becoming less distinct, everything reducing to shades of gray before true darkness arrives and the stars appear. If the sky is clear, if there aren't clouds blocking the view, clouds that reflect city lights and make the sky glow with artificial orange or pink, obscuring the stars, making it impossible to see anything beyond the clouds themselves, flat, featureless gray or black depending on lighting, hiding the universe that exists beyond them, the galaxy and the billions of stars it contains, most of them invisible even on clear dark nights because they're too faint or too far away or both. Their light too weak to trigger a response in human eyes by the time it crosses the vast distances involved. Light that left those stars thousands or millions of years ago. ancient light carrying information about the past, about how those stars were when the light was emitted, arriving now to be seen by anyone who looks up, who takes the time to notice the stars scattered across the darkness, patterns that our ancestors saw and that our descendants will see. The same stars more or less, though they're actually moving, drifting through space at different velocities, the constellations gradually changing shape, distorting over thousands of years, becoming unrecognizable over tens of thousands of years, though the changes are so slow that they're not perceptible within a human lifetime. The sky appearing fixed, eternal, even though nothing is truly fixed. Everything is moving, changing, evolving, but at different rates, some things changing so slowly that for all practical purposes they can be treated as permanent, as reliable, like the sun, which will continue to burn and provide light and heat for billions of years, long enough that the end of its life is not something to worry about, not something that has any bearing on anything happening now or anything that will happen in the foreseeable future, just a distant fact, a piece of information about what will eventually occur in a future so remote that it might as well be infinite, time enough for everything we know to change beyond recognition, for humanity to evolve into something else or to go extinct or to spread beyond Earth to other planets, other solar systems, possibilities that are imaginable but that depend on choices and circumstances that haven't been determined yet, futures that branch and multiply, that exist only as potentials, not as certainties, the shape of what will happen, emerging gradually as time moves forward, carrying everything with it, the sun and the earth and everything on the earth, all of it moving through time together, moment by moment, day by day, year by year, the sun rising and setting in its apparent motion, the real motion being the Earth's rotation, but the appearance being the sun moving across the sky, rising in the morning, climbing to its highest point at noon, descending in the afternoon, setting in the evening, disappearing below the horizon, leaving behind the afterglow, the gradual fading of light, the deepening of blue into indigo into black, the emergence of stars one by one, as the sky darkens, Venus appearing first if it's in the right position, the evening star, bright enough to be visible before the sky is fully dark. Then other planets if they're visible, Jupiter and Mars and Saturn, and then the stars themselves, more and more of them becoming visible as darkness deepens. The Milky Way appearing if you're far. From city lights, a band of light across the sky, the combined glow of billions of stars too distant to see individually but visible as a collective luminosity. A river of light flowing across the darkness, beautiful and mysterious, an indication of the scale of the galaxy. The sheer number of stars it contains, hundreds of billions at least, possibly more, each one a sun, many of them with planets, some of those planets possibly harboring life, though we don't know yet, haven't detected any signs, but the possibility exists, the probability even, given how many stars there are, how many planets there probably are around those stars. The odds suggesting that somewhere out there, perhaps in many places, life exists, though whether any of it is intelligent, whether any of it has developed technology, whether any of it has lasted long enough to develop the ability to communicate across the distances between stars, these are questions that remain unanswered, mysteries that might be solved someday or might remain forever unknown, depending on whether we develop the ability to detect such signals, whether anyone is sending them, whether the distances and timescales involved make communication possible, or whether the universe is just too large, too empty, the spaces between stars too vast for any meaningful exchange, each civilization arising and existing and ending in isolation, separated by distances that are effectively infinite given the constraints of physics, the speed of light limiting how fast information can travel, no way to send messages faster than light, no way to cross the gaps quickly enough to matter, time and distance combining to create a kind of loneliness, each star system isolated in its own bubble of space, the light from distant stars taking years or centuries or millennia to arrive, by which time anything could have happened. The star that emitted the light might no longer exist, might have exploded or burned out or changed in some fundamental way. The light carrying information that's outdated by the time it arrives, a record of the past rather than the present, the universe, revealing itself not as it is but as it was, every observation looking backward in time. The farther we look, the older the light, telescopes acting as time machines showing us the history of the cosmos, galaxies as they were billions of years ago when the light we're seeing now left them, those galaxies now older, different, perhaps unrecognizable if we could see them as they are now. But we can't, we can only see them as they were, the present moment of distant objects forever hidden from us, separated by the time it takes light to travel, creating a universe where everything is history, where the present exists only locally, here and now, this planet, this moment, everything else is past, ancient light from ancient sources, telling stories about what was, giving us a view of the cosmos that's like looking through a window into history, except the window is light years wide and billions of years deep, showing us a universe that's vast and old and constantly changing, galaxies colliding and stars being born and dying, planets forming and perhaps life emerging and evolving and ending. All of it happening somewhere out there in the darkness between points of light, in the space that looks empty but isn't, that's filled with gas and dust and dark matter, invisible but present, detectable through its gravitational effects, bending light, influencing the motion of galaxies, making up most of the mass of the universe despite being impossible to see. A mystery that remains unsolved, what dark matter is, what it's made of, why it exists, questions that scientists are working on but haven't answered yet. The universe still holding its secrets, still mysterious despite centuries of observation and study, still revealing new surprises, new phenomena that don't fit existing theories, requiring new ideas, new mathematics, new ways of thinking about reality. The process of understanding continuing, probably forever. There may never be a final theory that explains everything. There may always be deeper layers, more questions emerging as old ones are answered. The universe perhaps infinite not just in space but in complexity, endless depths waiting to be explored. If anyone is around to explore them, if humanity lasts, if we don't destroy ourselves, if we manage to survive the various challenges we face, climate change and resource depletion and the risks of technology, weapons and pollution and all the ways that civilization could collapse, possibilities that are real but not certain, the future still open, still undetermined, choices still to be made, individually and collectively, actions that will shape what happens, whether we continue or whether we end, whether we spread beyond Earth or stay here, whether we develop wisdom along with technology or whether we remain clever but unwise, capable of great things but also capable of great harm, a species still evolving, still learning, still trying to figure out how to live, how to exist sustainably, how to be in the world without destroying it, questions that are urgent now in a way they perhaps never were before, when there were fewer of us and our impact was smaller, but now we're numerous and powerful and interconnected and vulnerable, dependent on systems that are complex and fragile, systems that could break down, that require maintenance and care and attention like the climate system, like the biosphere, like the cycles of water and nutrients that support life, all of it depending ultimately on the sun, on the steady flow of energy from that enormous furnace 93 million miles away, that ball of hydrogen fusing into helium, releasing energy, sending light across the void, light that takes 8 minutes to arrive, light that drives photosynthesis, that warms the surface, that makes life possible, the sun constant and reliable, rising every morning, a fact so basic that it's easy to forget, easy to take for granted but fundamental, essential, the source of almost everything, the reason we're here, the reason anything is here, at least on this planet, under this particular star, in this particular corner of the galaxy, this small region of space where conditions happen to be right for a solar system to form, for planets to coalesce from the disk of gas and dust that surrounded the young sun, for one of those planets to end up at just the right distance, not too close and not too far, in the zone where water can exist as a liquid, where temperatures are moderate, where life could begin and evolve and diversify, leading eventually to us, to consciousness, to the ability to think about the sun and wonder about it, to measure it and study it and understand at least partially how it works, what it's made of, why it shines, knowledge that our ancestors didn't have, that was gained gradually through observation and experimentation and reasoning, through the slow accumulation of understanding that characterizes science. Building on what came before, correcting mistakes, refining theories, getting closer to an accurate picture of reality. Though the picture is never complete, never final, always provisional, subject to revision as new evidence appears, new observations that don't fit the current model, requiring adjustments or sometimes requiring throwing out the old model entirely and starting over with new assumptions, new principles, the process messy and nonlinear but generally progressive, moving toward better understanding, more accurate predictions, deeper insight into how things work, why they are the way they are, questions that have occupied human minds for as long as humans have existed, probably longer, questions that may have occupied the minds of our pre-human ancestors. Anyone who looked up at the sky and wondered, who noticed patterns, who tried to explain them, the sun and moon and stars moving in regular ways, predictable once you pay attention, once you track them over time. The ability to predict becoming useful, allowing people to know when to plant crops, when to expect seasons to change, when to prepare for winter, practical knowledge that was also maybe the beginning of science, the recognition that the world follows rules, that events don't happen randomly but according to patterns that can be learned, that can be used, that give some measure of control or at least preparation, the ability to anticipate rather than just react, a survival advantage that our ancestors had, that helped them succeed, that contributed to us being here now, descendants of people who figured things out, who solved problems, who adapted to changing conditions generation after generation, surviving and reproducing, passing on not just genes but knowledge, cultural information that accumulated, traditions and techniques and stories, ways of understanding the world, including the sun, including its importance, its centrality to life, the way it governs so much, providing light and warmth, marking time, dividing days, defining seasons, reliable and steady, rising and setting, forever, or as close to forever as makes any difference to human concerns, the end of the sun's life so far in the future that it might as well not exist, might as well be infinite, the sun effectively eternal from our perspective, always there, always shining, always providing what we need, expecting nothing in return, just existing, just being what it is, a star, one among billions, ordinary in the cosmic scheme but special to us, essential to us, the source of light and life and energy, the center of our solar system, the object that everything else orbits, that holds everything together, that makes this all possible, this planet, this life, this moment, the sun above or below depending on time of day, present even when invisible, its light reaching around the curve of the earth, scattered by the atmosphere, creating the blue of the sky, the colors of sunrise and sunset, the gentle gradations of twilight, all of it light from the sun, transformed and scattered and reflected, filling the world with illumination, making vision possible, making colors visible, making the world knowable through sight, one of the primary senses, perhaps the most important for humans who are visual creatures, who rely on seeing, who navigate by landmarks, who recognize each other by faces, who communicate through expressions and gestures and written symbols, all of which require light, require the sun, either directly during the day or indirectly at night through artificial light powered by electricity that ultimately comes from the sun, stored ancient sunlight in the form of fossil fuels or current sunlight captured by solar panels, the sun powering civilization, powering everything, all of its solar energy in one form or another, transformed and transferred and stored and released but fundamentally from the sun, from fusion in the core, from hydrogen becoming helium, from mass becoming energy, from matter being converted according to Einstein's equation, the most famous equation in physics, E=mc², elegant and simple and profound, showing that mass and energy are related, are different forms of the same thing, convertible into each other, a fact that makes the sun possible, makes stars possible, makes the universe as we know it possible, mass forming after the Big Bang, matter condensing from energy, galaxies forming, stars igniting, planets coalescing, life beginning, consciousness emerging, awareness developing, the ability to think and wonder and question, to look at the sun and ask what it is, how it works, why it exists, questions that have answers now, at least partial answers. The sun is a star, it works through nuclear fusion. It exists because a cloud of gas collapsed under its own gravity 4.5 billion years ago. Simple answers that lead to more questions, more details, more complexity, layers upon layers of understanding, but at the core something simple. The sun shines, the sun provides, the sun is there, and that's enough, that's everything, the basic fact that makes the rest possible. Light traveling 8 minutes through space, arriving here, falling on this planet, absorbed and reflected and scattered, filling the world with brightness during the day, absent at night, creating the rhythm that structures life, day and night, light and dark, wakefulness and sleep, activity and rest, the cycle that everything follows, plants and animals and humans, all of us adapted to the presence and absence of the sun, to the light that comes and goes, regular as anything in nature, reliable, predictable, the sun rising tomorrow and the next day, and the day after that, continuing, persisting, shining, burning, existing, steady and constant, 93 million miles away but present, affecting everything, essential, central, the sun, our sun, the star at the center of the solar system, ordinary and extraordinary, familiar and mysterious, known and unknowable, close and distant, always there, in the sky or beyond the horizon, above or below, present or hidden but never gone, never truly absent, just temporarily out of view, the earth, rotating to bring us back into the light, morning coming eventually, dawn arriving, the sun returning, appearing again on the eastern horizon, climbing into the sky, bringing another day, another cycle, the pattern continuing, the rhythm persisting, steady and eternal or close enough, the sun shining, always shining, light traveling through space, reaching us, warming us, sustaining us, the light that makes life possible, that makes this moment possible, falling softly now or soon, gentle and persistent, the sun, there, always there, shining.